All right, number 12. So we have a pot of coffee is in a room with a temperature of 68 degrees. After 10 minutes, the temperature of the coffee has decreased from 108 to 100. Find the temperature after another 10 minutes. Round your answer to the nearest tenth. Okay, so the first thing we have to do is set up an equation and find our cooling constant K. So this is our original formula, Newton's law of cooling, which you will be given. Now, your surrounding temperature is the temperature of the room, which is 68. Your D sub 0 is going to be the difference between the original temperature and the surrounding temperature. So it says it decreased from 108 to 100. That means your 108 is your initial temperature. Okay, so like T sub 0, that's your initial temperature. So you are going to take your initial temperature, T sub 0, subtract 68, which is the room temp, and that's going to be 40. So that's your D sub 0. Okay, another way you can think of D sub 0 is temperature of the surroundings temperature of the object, the initial temperature of the object, minus the temperature of the surroundings. Okay, because it's the difference between those two. Okay. All right, so you should get 40. Now, it says after 10 minutes, the coffee decreased from 108 to 100. So that means after 10 minutes, the coffee was 100 degrees. So I can plug in 10 for the time, 100 for the temperature. After 10 minutes, it was 100 degrees. And then I'm going to solve for K. So I'm going to subtract 68 from both sides, then divide by 40. Then I'm going to take the natural log to undo E. Then I'm going to divide by negative 10. And then your constant, if you round that out to 5 places, that would be definitely a good place. Now your K should be positive here so that when you plug it into your model, you do have a negative. Now here's the tricky part. It says find the temperature after another 10 minutes. So how many minutes were there to begin with? It says after 10 minutes, and this says after another 10 minutes. So the total time that has passed would be 20 minutes. Okay, so the total time that you'd be plugging in is going to be 20. And then you are going to be evaluating. So once you do 68 plus 40 times e to the negative 0.02231 times 20, if we round our answer to the nearest tenth, we're going to get 93.6 degrees Fahrenheit. All right, good job. Hope you studied hard. Good luck on your test. Bye. Get math or cry trying.